Welcome to the CAD Office training series for FDOT Connect for OpenBridge Modeler. My name is Heather Piorin, and I'm a structural engineer with WSP USA. In this video, we'll be covering exercise 4.1 from the Bridge Design 3D Modeling and Plans course guide. This exercise demonstrates the use of data communicated from other disciplines. Let's get started. Before we start on the exercise itself, we'll talk a little bit about working with other discipline files in general. We'll go over some best practices as well as some legacy methods of importing data if you don't have the data that you need in ORD. We'll then jump into exercise 4.1, where we will use a data set to reference in roadway data, the alignment and profile, as well as the super elevation models. We'll then reference in the survey data, which in this case is the terrain model, and then we'll explore features of the terrain model using override symbology. After that, we'll use a fence to clip out data that is outside of the bridge area that we don't need while we are doing a bridge model. In terms of working with other discipline files, you want to make sure that you're always referencing those files and that you do not open them live. In most cases, you actually won't be able to open them live within OBM since most other disciplines use Open Roads Designer, which although it has the same DGN file extension, won't open within OBM because it has a different schema. You also want to make sure that your reference files are coming from the same project workset, so that's the FPID in most cases. If not, when you reference the files, you'll get an error message that'll pop up, although you could disregard that error message in a pinch and proceed with the reference. When we're referencing ORD alignments, we are able to adjust the scale within OBM and it won't affect the source file at all. So the result of that is that you no longer need to have multiple models for different annotation scales unless there is a text placement issue with annotations. In general, in ORD, they start in 2D and then it essentially gets projected up into 3D, which is actually the opposite of OBM. When we model a bridge, it goes straight to 3D and then the 2D decorations get projected down to the zero elevation afterward. We'll start exercise 4.1 by opening the 4.1 Begin DGN. In these videos, we'll always start with the _begin files, but if you are working through the exercises in sequence, you are welcome to continue working with the file from the previous exercise. We'll first double check that we're in the FDOT workspace and that we are in the work set of the data set that was downloaded from the FDOT website. After we confirm those, we'll click Browse and we'll navigate to the B01 MODLBR TR01 _ 4.1 _ begin. We'll click Open. All right, you'll see that this is a completely empty file, no elements found. So this is the first step in creating a bridge model. So we'll go to Home and then select References. In our case, it's already been pinned to the bottom here. And then we will go and click the Attach Reference button. And now we'll navigate to not within the Structures folder, but if we go one folder up and over to the Roadway folder, we've now got the ALGN RD01 file. So we'll click Open. And then in this reference attachment dialog box, we'll double check that the model that we're attaching is the default model. And then all the other settings look good. And we will click OK. So you won't be able to see anything, but if I click Fit View, then you'll see that we now have this alignment in our file. So this is a reference to the alignment file that was provided by Roadway. So we'll double check our references. Looks like we've only got the default model attached. I do want to make a note that there are other models in here. We're going to attach the super elevation model next, but sometimes when you attach an alignment file, the default 3D model comes in as well. If that one comes in, that's okay. We'll just toggle it off in the display. So in this case, we don't have to toggle anything off because we only got the default. The default is the 2D alignment, and that's the one that has the actual information associated with it. So the 3D is the vertical profile that's associated with the alignment, but it's, we'll say, the dumb model because it doesn't have any of that information attached to it. This alignment file actually has both the alignment and the associated profile attached to it. So this is the one that we're going to target for our OBM model. So we'll go back to our references. We'll click attach. We'll go up to the roadway folder again. We'll attach the ALGN file, and this time we'll select the super elevation model. We'll click OK. Now you can see that this super elevation shape appeared here. So if I were to select that, I could actually, in the properties, I could go through and take a look at the super elevation information that is attached to this super elevation model. So the super elevation model can make it easy to have a super elevation transition on a bridge. You'll first define the typical cross slope of the bridge in the bridge deck template, and then afterward you can apply the super elevation on top of it, which will override the cross slope, and that'll make the bridge deck follow the proper super elevation transition. So that's the purpose of the super elevation model and how it works within the OBM model. So after we have our alignment file referenced in twice, the default model and the super elevation model, now we will attach the terrain file. So again, rather than the structures folder, we're going to go up one level, and then we'll go over to survey. Within survey, we have this serve RD01 DGN. You can see in the little preview, that's got our terrain in it. So we'll click open. We'll confirm that the model is the GTD MRD file. All the other settings are good, and we'll click OK. As a note, the terrain model may be a model within the serve RD01 file, or it may exist in a separate GDT MRD DGN file. So we can go ahead and fit view again, and now we can see the extents of the terrain file and then the extents of our alignment. So one thing that we'll notice if we zoom in, that we've got some tick marks, but when we zoom in, they seem to disappear, and that's because they are very small in terms of the scale. So we'll go into the Reports and Drawings tab, and then within the Drawing Scale group, we'll see that right now that's set to full size. So we'll click that drop down, and we'll scroll down to 1 inch equals 30. And you'll see that once I select 1 inch equal 30, now all of our tick marks and our annotations are legible. So now we're going to go through and take a look at our terrain file and see how we can view the information of the terrain file in a few different ways. So we'll go ahead and open up the terrain model. So we'll select the terrain model itself, and you could either, if you don't have it docked, you can go in the Home tab, in the Primary group, and select the Properties window. And in my case, I've already got it docked over here on the side. So what we can do with the terrain model selected in the Properties window, we can scroll down to this Override Symbology option, and we'll select, rather than no, we'll select yes. And you'll see once we select yes, all of these calculated features display and source features display go from gray to now selectable. So we can go through and toggle I guess the most popular one is triangles. We'll set those to on. So when we toggle the triangles to on, now all of the surface triangles are available. So we can go through and take a look in view 2, which is our isometric view. We'll go fit view, and then we can go through and take a look at the terrain here. So not incredibly exciting, but you can see the different terrain, and this, as you can tell, is some fill approaching a bridge over here. So we can go through, take a look at some, any gaps that may be there, any anomalies, stuff like that. Navigate around, take a look at our terrain here. So there are other things that we can take a look at with the terrain file as well. Let me go back to view 1, select the boundary, and we can take a look at a couple other features. So we'll turn the triangles off. So the other items are the kind of the major contours here, and then the minor contours. Major and minor contours. If we zoom in, we can see what those contour elevations are. Turn those off again. And then another element you can take a look at are these break lines. So break lines are used to represent an edge of pavement, a ditch bottom, or any other abrupt change in slope. So the triangles that we looked at a moment ago will not cross a break line, and it kind of keeps it from averaging elevations that are too far apart. So we'll go back, toggle these back off, and then override symbology back to no. So what the override symbology does is, as you can see, it allows us to view various features of the terrain without making any changes to the terrain file itself. So as the name implies, we're overriding whatever the symbology of that reference file is. So regardless of whether I turn on all of these features, the terrain file itself is not going to have those features turned on. So that's the purpose of the override symbology option. So in order to better navigate the model, so that when we go to fit view, we don't have this larger extent, we're going to place a fence in this area, and we're going to clip our reference files. So in the Home tab within the Selection group, we'll click Fence Tools. So we're going to place a fence, and more or less you're just going to cover the area where the super elevation transition is. So we'll left click up in the top corner, drag down here, and second left click in the bottom right corner. Once the fence is placed, we can go back into our references dialog box, which you can either access through the bottom here if you have it docked, or if not, you can click the references button in the primary group. So we'll go ahead and select the first reference and then hold shift, click the last reference so that we are clipping all three references at the same time. And then we can select the clip reference button, and then we'll keep the method as active fence, and then we'll left click in the view window, and now we have our extents limited, where if we zoomed out or got away from the area and we click fit view, now it's going to fit into a more zoomed in view of where our bridge is at. So before we start modeling the bridge, we're going to go into our references again, and we're actually going to turn off both the super elevation model as well as the survey model. So now all we have is this segment of alignment here, which is all that we need to start modeling the bridge. Thank you for watching this section of the training series for FDOT Connect. Additional training videos and course guides are available on the CAD Office Training webpage, which may be found at fdot.gov/CAD.